the Bode plots for them. I'm making some videos that have more information about like the concepts, so if you want to look and keep an eye out for those. I've only made one so far, but I will be making some more of those. And so let's just go ahead and start. So the first one I have, what is the first one that I have? Uh-huh. Thank you. So we have 10 j omega plus 10 over minus j omega squared plus 3j omega. So the first thing we have to do is get this in the right form and then try to figure out, what are the various parts of it. So we want all of our factors to start with 1 plus. And so I need to factor a 10 out of the numerator. And when I do that, I get 1 plus j omega over 10, and I still have this other 10 out in front. And then in the denominator, I will factor out a j omega, and then I'm left with, I actually think I wanted, well, let's see what happens. Then I have minus j omega plus 3. Yeah, I think I wanted this to be, no, that's not right. I would have just omega plus 3. What's that?
Negative omega?
Negative omega, and I meant to have no j here. Yeah, when I wrote that. But I need this to be j omega, so I need to have a j in there. So let's see, what did I actually want to have here? I may have messed all of these up. Hold on. I want to end up with j omega times 3 plus j omega. So that would have originally been minus j omega squared plus 3j omega. Right. So that is okay. So why am I getting confused? Yeah, right. Because
No, you're right.
no, that just gives me minus omega squared, not minus j omega squared. So I just needed this to be minus omega squared. That's what I needed. So if I have a minus, and so I'm going to have to remember that on my other problems. So if I have a minus omega squared, but I need a j omega in my problem, then when I factor out a j omega, then that gets me what I wanted. So the original problem that I should have written should have been 10 j omega plus 10 over minus omega squared plus 3j omega. That should have been the original problem. And then in the numerator, I factor out the 10. in the bottom, if I factor out a j omega, then when you divide -1 by j, you get j. So this leaves me with j omega plus 3. But now I need to get that 3 out of there. So now I'll have 100 times 1 plus j omega over 10 over 3 j omega 1 plus j omega over 3. So my constant is 100 over 3. And then what are the other parts of this one? So what else do I have? Hundred over 3. Sorry. So what do I have from the top term? Yeah, so what that gives us when it's in the numerator, that gives us a simple 0, and it tells us that omega c is at 10. And in the denominator, this j omega gives me a pole through the origin and this term right there gives me a simple pole with corner frequency equal to 3. So the terms in the numerator give me zeros, and terms in the denominator give me poles. Nothing is squared, so there's no quadratic. So then if you go back and look at these, you can see for our constant term, we want to take 20 times the log of the absolute value of the constant term. So I want 20 log of 100 over 3. And that gets me 30.45. So that's going to be the first thing that I put on my plot. Okay, so I put a horizontal line at about 30. And that's my constant term. Next, I'm going to do the pole through the origin. So a pole through the origin or a 0 through the origin goes through 1. And if it's a pole, it has a slope of -20, and if it's a 0, it has a slope of 20. So a slope of -20 means that I'm going to go up and to the left or down and to the right. And so I want to go down 20, and then I want to go over till I'm at the same place in the next decade, so the same type of vertical line. And it's going to be 20 each time.
So is that 20 times log of omega c? Is that where you're going to start from?
No, the slope is always going to be 20 for a pole. The slope is 20, negative 20. So, so for a pole, the slope is negative 20. For a zero, the slope is plus 20. And it will, if it's of a higher order, so like if my term was squared, then it would be 40, or if it was cubed, it would be 60. It's n times that number. So it's always a multiple of 20. I'm going to make a video explaining where all this is coming from, because it never really made sense to me, because it's just like, okay, fine, I can do this, but I don't know what I'm doing. And so I don't want to take up time doing that here, because it's not going to help you do anything on the test, but I want to do it because for me it helps me kind of accept it, say, okay, now I know why I'm doing this. So just for right now, you can just believe me that it is going to be a multiple of 20, and when my term is just to the first power, it is just going to be 20. So that is my pole through the origin. And then then we have a simple zero with corner frequency 10. Okay, so the way it's listed on this worksheet that says that I got has the approximation. It says the low frequency approximation is 0, and the high frequency approximation is, are we doing a pole or 0? I don't remember. A 0. The high frequency approximation is at 20 decibels per decade. That's the slope part. So the low frequency is at 0 until you get to the corner frequency, and then you have a slope of 20. So the 1 plus j omega 10, the corner frequency is 10, which is right here. And until you get to 10, it's 0. And then after that, it's a slope of 20 decibels per decade. So you go up 20 and then go to the same spot on the next decade. So zeros have slopes of positive 20. And then the last one we had was a pole with corner frequency 3. So we'll go to 3. And so if this is 1, that's 2, that's 3 right there. So a pole, a simple pole, is 0 until you get to the corner frequency, and then it has a slope of negative 20 decibels per decade. So to get that right, I go down 20, but then I go over to the same vertical line pattern. So I was at 3 here, so I go to 3 in the next decade. That's like 30, because this is 10, this is 10, 20, well, I didn't put it there, I put it at 40. So this is 10, 20, 30, and then I'd put it at 300, so this is 100, 200, 300. And now to get my composite, I'm going to add these all together. And to start with, I need to get my starting number. So my starting number is going to be the sum of these two numbers right here. So I had my number of 30.4 from my constant term, but this pole through the origin also gives me a value of 20 right there. So I have to add those together. And I get 50.4. Which I don't have my plot to be big enough for that, but all right, so I start at 50. Now I need to look at the slopes. From here on out, I'm going to be adding slopes. So at this point, the only thing that doesn't have slope 0 is the pole through the origin, and it has a slope of negative 20. So I'm currently at 50. I want to go down by 20 because my slope is negative 20. So 50 minus 20 is 30. So at the next decade, I will be at 30. Still, nothing else has changed. I still have a slope of negative 20 until I get to 3. So I'm going to keep going until I get to 3. At which point, I now have something else that has a slope. I now have two things that have a slope of minus 20. So minus 20 plus minus 20 is minus 40. So now I have a slope of minus 40. And so I need to go down 40. Right now, I'm a little less than 20. So if I go down 40, I'll be a little less than negative 20. And then I want to go over to the same place on the next decade, which is right here. So my slope just got slopier. And now I see that I have at whatever number this was. What number was that? Oh, I shouldn't have stopped. I should have stopped here. Should have stopped at the green one. Yeah, that doesn't, okay. So let me erase that. So I needed to only go to where this next change was. So I need to have a slope of negative 40. So I'm still gonna like estimate that slope the way I was doing it. I'll go down 40, so I'm a little less than 20, so I'll be at a little less than negative 20 at the next decade. So this is where my line would be if it continued all the way through. But I have to stop where this green line started, because that's where I next have a change. So I'm only going to fill in to here. Because at this point, I'm now adding in another slope of plus 20. So I was at a slope of negative 20. So negative 20 plus 20, negative 40, sorry, I was at a slope of negative 40. Negative 40 plus 20 is negative 20. So now I have a negative 20 slope again. So I want to go to the next decade and down 20. Which would put me about right there. And then there's nothing else that happens after that, so it's going to continue with the same slope. So we just had this little part in here where we had a little more of a slope. And I don't know if y'all can see over there, this top graph shows the actual graph. Our pink line is a straight line approximation to that one. So it just shows you that it gets the Bode plot gets a pretty good approximation. It just has a little bitty bit in the middle. So were there questions on that one?
So to get the composite value, you had the middle from the log and then the slope.
So sort of. Zeros have an E in it? Okay, so what these words are saying is our Bode plot graphs generally start at point 1. The reason they're starting at point 1 is we can't really start at 0 because our function isn't really defined at 0, and you can't take the log of 0. So 0 really isn't even on this graph at all. So if you look, it goes from point 1 to 1. So these lines are 0.1, 1, 10, 100, 1,000, and so forth. And so we're used to thinking of this as like our y-axis. But here, it's at 0.1. And we're going to have a value from our constant, but we also are going to have values from poles and zeros through the origin. And the reason why is simple poles and simple zeros are, like, let's say I had j omega plus, or 1 plus j omega over 20 on top and 1 plus j omega over 300 on bottom. So this is a 0 with corner frequency 20. So that would mean, so here's 10, here's 20. It is going to be 0 until I get to 20, and then it will have a slope of 20 after that. My pole is going to be 0 until I get to 300. Here's 100, 200, 300. And then it will have a slope of negative 20 after that. So simple poles and simple zeros are going to be 0 right here. They're not going to give you anything. But poles and zeros through the origin go through 1, 0, and they have a slope of either plus 20 for a 0 or minus 20 for a pole. So if I have a 0 through the origin, that has a slope of plus 20. So it looks like that. That's a 0 through the origin. And if I have a pole through the origin, it has a slope of minus 20. So it looks like that. If I had j omega squared times 1 plus j omega over 20 over 1 plus j omega over 300, then I would have a 0 of order 2, so that would have a slope of 40, so that would go through 0, and it would have a slope of 40, so it would look like that. So when I'm getting my starting value, I'm adding these things up. Now, you're only going to have two things. You'll have your constant, and you'll either have a pole or a 0. You're not going to have both a pole, through the origin. You're not going to have both a pole and a 0 through the origin, because let's say we did. Okay, so let's say I had j omega squared over j omega. What could I do here? Yeah, I could just cancel it, and then I just have a 0. So you're either going to have, through the origin, you'll either have a 0 or a pole. You're not going to have both. So you'll have two numbers over here. You'll have your constant number, and you'll have your number from that you're going to add up. So that's why I'm saying you'll take your value of 20 log k, and then you'll add together any numbers you have from those, and that gets you your starting value. And then after that, you at any time you have a change, figure out your slope by adding all the slopes at that point in your graph. So on our graph, remember the pink line, that's our composite. So that one we're not adding in. At point 1, we have slopes of 0, 0, and negative 20. So we add those together to get negative 20. When I get to 3, now I have slopes of negative 20, negative 20, 0, 0, and 0. So now I have a slope of negative 40. And then when I get to whatever this next one was, I now have slopes of negative 20, negative 20, positive 20, and some zeros, and I add those together to get positive 20, to get negative 20. Negative 20 plus negative 20 plus positive 20 is negative 20, and that gets your slope. So was that more answer than you wanted?
That was great.
Okay. Okay. All right. So now let's get the next one. There's no telling if I got this one right. The reason why I'm not certain is because in later classes you won't be using j omega, you'll be using s, and s is j omega. It's just rather than writing j omega, you write s. And so I had to go from s's where I got these examples to j omegas, and the j's sometimes mess with me. So I know I want to factor a 4 out of the numerator, and that would leave me with minus, yeah, I don't want this j here. That would leave me with minus 4 omega squared plus 4 omega. Oh no, I don't want to factor out a 4, I want to factor out 100. Because I need to get 1. I need my constant term to be 1. So I'm going to factor out a 100 and no j there. And then I get minus omega squared over 25 plus j omega over 25 plus 1 over, and out of the denominator, I'm going to factor out a j omega squared. So I'll factor out, really I'm factoring out a negative omega squared. So I'm factoring out a negative omega squared, and I'm left with j omega plus 100. Ooh, I think I got that right. I did. Okay, so now I have 100 times 1 plus j omega over 25 minus omega squared over, oh, so this minus omega squared over 25 becomes plus j omega over 5 squared. I need that last term to be in parentheses squared to get my corner frequency for a quadratic term. And then I have j omega squared, and then I'll factor a 100 out of that other term, and then I get 1 plus j omega over 100. And then my 100s cancel. So I have 1 plus j omega over 25 plus j omega over 5 squared over j omega squared and 1 plus j omega over 100. Okay, so the top is a quadratic term, so that's a quadratic 0. So we have a quadratic 0 corner frequency 5. I have a pole through the origin of order 2, and I have a simple pole with omega c equal to 100. And my constant is 1. So I'll take 20 log 1, which gets me 0. So that's nice. So I have a horizontal line at 0. And then I have a pole through the origin of order 2. Okay, so things through the origin go through 1. It's a pole, so it has a negative slope. It's of order 2 because it was squared, so that means its slope is negative 20. So that means it's going to go through 40, and then it'll go down, and down 40, and then over 1, and then down 40, and over 1. So this will be our pole of order 2 through the origin. That's not very good. Okay, then we had a quadratic 0 with corner frequency 5. So a quadratic 0 with corner frequency 5. Quadratics have slopes of 40. If it's 0, slopes of positive 40, and if it's a pole, it's a slope of negative 40. And so it had a corner frequency of 5. So that's 1, 2, 3, 4, 5. So it'll be 0 until it gets to 5. And then after 5, it'll have a slope of plus 40. So I want to go over to, so this was at 5, so I'll go over to 50. So that's 10, 20, 30, 40, 50, and up 40. And that gets my quadratic 0. So for my composite, I'll start by adding together the numbers I get from my constant, which was 0, and my poles and zeros through the origin, which was 40. So I'll start at 40. And then I look at the slopes I have. To start off with, the only slope I have is negative 40. So to start with, I'm going to be going just right along this curve, or this line, until I get to the first place where I have another change. Did I leave out a term?
Yeah, you can do a simple pull at 100.
Okay, yeah. Okay, well that's not going to change this. That'll be fine. It'll show up later, so I don't have to erase what I've done so far. Okay, so a simple pole at 100 would have a corner frequency at 100, and it'll be 0 until you get to 100. And then once you get to 100, a simple pole of order 1 will just have a slope of negative 20. So it's 0 until I get to 100, and then a slope of negative 20. Okay, So it still is true that nothing happened until I got to 5. And once I'm at 5, I have slopes of negative 40 and positive 40, so those cancel out and give me a slope of 0. So I'm just horizontal until I get to my next corner frequency. And now I have a slope of negative 20 because I have a negative 40, a positive 40, and a negative 20 will get me a slope of negative 20. So it'll look like that. Okay, so I'll get started on this next one. I don't know if I'll have time to finish it. So I'm skipping, oh no, I'm doing number 3. So 60 plus j omega 600 over negative 2 j omega squared plus, and I don't want that j there, just negative 2 omega squared plus 6j omega plus 100. So that equals, if I factor out a 60, I get 1 plus, nope, if I factor out a 600, no, factor out a 60. Yeah, factor out a 60. I get 1 plus j omega plus 10 j omega over, and if I factor out a 2, I have a 200. I have negative omega squared plus 3j omega, no, I factor out a 100. Factor out a 100, and I have negative omega squared over 50 plus, what was I thinking? This is not the problem I meant to do. Let me see if let me see what I really meant to do. I really meant to do, didn't want something with such unpleasant numbers. Yeah, I did not mean to do that. Yeah, let's do this one instead. So this is just a different one. So this one is h of s equals, or j omega, h of j omega equals j omega plus 1 over minus omega squared plus 110 j omega plus 1000 with a 100 in front. So the top is already in the right form. The bottom, you could rewrite this as 1000 plus 110 j omega plus, in parentheses, j omega squared. And if you do that, you can see that it factors into 100 plus j omega times 10 plus j omega. Did y'all see that fancy factoring?
Mhm.
So then I can factor out from the first term, I can factor out a 100, and then I get 1 plus j omega over 100. And from the second term, I can factor out a 10, that's times 10, 1 plus j omega over 10. So I get 1/10 times 1 plus j omega over 1 plus j omega over 100 times 1 plus j omega over 10. So what do I have on this graph? What are my different elements that I'm going to need to put on my Bode plot?
There's a 0 on the top.
Okay, so I've got a simple 0.
There's going to be
What's the corner frequency?
0,
It's 1.
1.
Okay,
And then 1 over 10 gives you negative 20 for the constant.
okay, so I've got a constant, and it is going to be negative 20. It's going to be, 20 log 1/10, which when you do that will give us negative 20. Okay, and then what else do we have?
Here's the bottom 2 different poles.
Yep, we have 2 simple poles. One with a corner frequency of 100, and one with a corner frequency of 10. So then we would have so our constant term gave us negative 20, and then we had 0 with a corner frequency of 1, so that's 0 until you get to 1, and then a slope of 20. And then we had a simple pole with a corner frequency 10. So there'll be 0 until you get to 10. And then a slope of negative 20. And then we had another simple pole with corner frequency 100. So that'd be 0 until you get to 100, and then a slope of negative 20 after that. So then our composite will start at negative 20, and there's no slope to start off with, so it'll just be horizontal until it gets to 1, where it'll have a slope of plus 20. And then when it gets to 10, there's a slope of plus 20, a slope of minus 20, so it'll level off. And then when it gets to 100, it'll have a slope of minus 20, so it'll just trace over that one. Did that one seem easier after, like, doing some of the harder ones? No?
No, I mean, not for me. I still don't really grasp the concept well. But
Is it making a little more sense?
no, it makes sense now. 'Cause
Okay.
When I went to the session, I didn't know anything about these.
Yeah, I knew nothing about it before I went here, and I feel like I know how to do one. I just have to remember the formulas, I guess.
Yeah, it's like with everything else. You just have to do a few of them, and once you do a few on your own, like without my telling you, what to do. When you have to like flip back and figure it out, and you'll make a mistake, and then you have to go back and fix it, and then you'll make another mistake, you have to go back and fix it. Once you've done that a few times, it'll really start to crystallize. Because it really is, the, the learning part actually comes from fixing your mistakes. So, all right, so that is all I have for today.